In this video, I'm going to talk about the memory location in C language. When we create a variable, basically it has two things, a value and a memory address. I want to create a variable int x equal to 5. This number 5 is the value of the x. So let's print the value of x. I'm going to write printf the value of x is %x. So I want to combine that. As you can see, the value of x is 5. So what is the address of 5 in memory? As you know, this number 5 is stored in memory, in RAM in our computer. So in memory, we have billions of places, billions of locations that the numbers can be stored. So this 5 is stored in some of those locations in RAM. So we want to print the address of this 5 in RAM, the location of 5 in RAM. I'm gonna write here again, printf, the memory address of x is x/n. Let's use here \n. So I'm gonna write here %x, and here I'm gonna use $x. In order to access the address of a variable, we use the ampersand. So let's print. As you can see, the value of 5, the value of x is 5. The memory address of x is this number, 327FFB8C. This is a hexadecimal number. This is a very, very large number. What is the hexadecimal number? Hexadecimal is number in base 16. In order to show the large numbers, we use the hexadecimal because we have billions of location, billions of memory in RAM. We use the hexadecimal number to show them. Hexadecimal starts from 0 until 9 and A until F. So I'm going to write here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. This is the hexadecimal number. This is 16 number. 0 until 9 is 10, 11, 12, 13, 14, 15, and 16. They are the numbers and letters to show the hexadecimal number. As you can see here, there we have numbers 3, 2, 7, and we have F, double F. The F is the last number in hexadecimal, and B, 8, C, we have here C, B. They are the letters to show the hexadecimal number. So a variable has a value and a memory address. In order to show the memory address of hexadecimal, we use the placeholder %x and ampersand. If you remember, we have used the ampersand for a scanf function. The scanf function also accesses the memory address of a variable. I'm going to write here printf enter a number, and here I'm going to use the scanf function, scanf %d, and here let's make another variable before that. I'm going to write here int y is equal to 0. So here I'm going to write ampersand y. I'm going to write printf the value of y is %d y. And I'm going to write again here printf the memory address of y is %d, %x, and %y. So let's print. I'm going to compile it. The value of x is 5. The memory address of x is D7FF8EC, and enter a number. I'm going to enter the 7. Let's hit enter. The value of y is, let's use a \n here. Right here, \n. And also I'm going to use a \n here. Let's compile it again. Internal number, I'm gonna write 7 again. The memory address of Y is 137FF978. This is the number of location of 7 in RAM. So to sum up, I have to say that a variable have a value and also a memory location. In order to access a memory location, we use the ampersand, and the scanf also accesses the memory address of a variable. In the next video, we're going to talk about the pointers, and understanding the memory location is an essential point to understand the pointers. See you next video, and bye for now.